In today's data-driven world, the role of a data engineer has become increasingly important. As more and more companies realize the value of their data, they seek talented professionals who can build the infrastructure and pipelines to collect, store, process, and analyze massive amounts of information. However, the competition is fierce, and with data engineering becoming one of the hottest tech roles, how does one stand out in the crowd? In this episode, we sit with Shaine Ismail, a principal engineer and co-founder of BigSpark, as he walks us through his journey and what he believes the next generation of engineers should be looking out for in the data space. Enjoy today's episode. This episode is brought to you by BigSpark. BigSpark is the UK's fastest growing data solutions consultancy, translating your business needs into data architecture, strategy, and engineering. Together with their technical partners, they focus on swift and efficient business value delivery. Taking an innovative approach to every challenge, BigSpark is an agile team of over 100 world-class engineers and data scientists pushing the boundaries of what can be achieved with AI, data, software, cloud, and machine learning. To find out how BigSpark can ignite your data solution, visit us at www.bigspark.dev. BigSpark, igniting change through engineering. Hello everyone and welcome to the Tech Step Podcast, where we navigate today's tech wave one electrifying conversation at a time. I am your host, Raymond Kluche, and today I have my able co-host, McLean, here with me. And today we have a special guest, an amazing guest for that matter, our boss, from BigSpark here to, have an interesting conversation with us. I wouldn't want to, go into all the juice for this episode. I'll let him, give us all the good stuff. So without further ado, I will first like to say welcome, Shaine Ismail. Thank you so much for making time to, join us on this podcast, regardless of your very busy schedule. And in the shortest amount of time, we just want you, to introduce yourself briefly, and then we can get into today's episode.
Hi, thanks Raymond, thanks McLean. It's great to be here. As I said, I'm Shaine. I've been a software engineer for more than 2 decades now. I started my career at in telecoms with BT. Spent a chunk of time in retail. Done the majority of my career in finance, mainly investment banking, working in fixed income and rates. Most recently, the last 10 years or so, been focused on the big data ecosystem, working for Deutsche Bank and NatWest, respectively, on their big data implementations, and introduce things like Kafka and stream sets and SAS and data science within NatWest. Been busy for the last few years.
That's quite interesting. We will delve a little bit into your background. So you did mention a bit of, finance and everything. I know you have a background in economics, and one will say, there was a good career out there for you. You could have potentially, gone down the path of becoming an economist and just, have a great career from there. Then you just choose to leave economics and go into the tech space. Can you tell us a bit about that economics decision as a study?
Yeah. So it's a great degree.
Yeah.
Okay. Yeah, it's a great degree to engage in. It does teach you about the fundamentals of, modeling and the economy and how things sort of systems interact. So in those ways, there's a lot of analogous understandings and knowledge of how things interact.
Oh, yeah.
One of the things that you sort of need to be aware of with economics is there's sort of 2 paths, right? You can either be a storyteller or you can be an analyst. And beyond that, and to stay in that economic trend, I didn't enjoy the storytelling, and frankly, the daily grind of an analyst, of doing the work, was just not for me. I enjoy spending time in Excel. I do enjoy building a good model, but if that's the only thing I've got to do on a daily basis, that's not really where I wanted to end up in my career. So I made the decision after doing an internship and doing a bit of work in this field, I made the decision to sort of stop and reassess and go, okay, what do I really enjoy? And I enjoy the econometrics, I enjoy the analysis, and I enjoy building the models, right? And that sort of swayed me towards the programming element, because that is very much like proto data science from 25 years ago.
Right.
Taking large amounts of data, modeling it, coming up with some sort of rarefied conclusions from that. That was it, really. And that's made the decision to actually, I quite enjoyed, you know, programming and working with computers,
Mm.
and taking that step where it wasn't just Excel, it wasn't just a bit of VB code or a bit of basic, to sort of learning, structurally learning how you can drive through change. It
Right.
sort of was sort of important to my career.
All right. That's quite interesting. So, software engineering is not data engineering necessarily. One would say software engineering is, data engineering is applying software engineering principles to data. But then you said you went into, the big data space, and that's data engineering for that matter. How did you get started with that? Would you say your background from economics, coupled with your programming skills, just led you up there, or you were just curious, or someone just, told you about the space and you decided to hop on?
Back when I started, there wasn't a separate discipline of data science, so
Mm,
or data engineering. Essentially, it was just the work, right? So I went from, you know, building analytics, right? Um, Bond pricing analytics. I was my daily driver. That's what I did every day. So I had to scrape through the data, make sure it was the right shape, build the model to go with it, make sure the model was consistent, testable, and we could validate it, and then make sure the output went to the right place in terms of reporting and
mm,
BI. So within that, you've got the pillars of data sourcing, data engineering, data science, BI, and reporting, and
mm,
then largely you're responsible for taking that thread of being organized, make sure you're reporting, doing all of the things you need to do in order to be functional. So as we've got through time, right, there's been a specialization in terms of skills. Now, I was able from a very early age to, in terms of my career, to
mm.
take, unstructured data sources and pricing from bond pricing or
Right.
FX pricing that were coming on in a stream, and take those and have to put them into a structured form and then
Mm,
calculated analytics of back them. That pretty much sounds like data engineering to me.
right. Right.
Different label,
Right.
different process, right? Different tools. Because back then there was the Python existed, but it was all Perl and Sybase and Java. Whereas now the sort of the world's moved on, and you've
Mm,
got Python, and you've got Spark and Scala and R. Um, uh, that wasn't a funny joke, but made me laugh.
so obviously, we are talking with someone who has a wealth of experience. You're talking about 10 years. I don't know you, McLean, but 10 years ago, I probably was, struggling in my computer science or IT degree, still wondering if I wanted to do that as a career. But you were in the industry. So I just want you, to tell us how, from where you stand, how data engineering has evolved for the past 15 years. Maybe just take us back from, like a timeline of a sort. Yeah.
So I think data engineering historically had always been that desk aligned, business aligned function where we took data out of technology systems and turned it into a usable form.
Mm,
So back when I was working in BT Internet, doing the telecoms industry,
all right.
the whole data engineering experience was in Excel. We would
Mm,
source the data from the source systems, and those reports would come in CSVs or Excels or database extracts. We would load them in. We would write a load of VB to turn them into the right shape, and then we would turn them into the outcome or the asset that we're interested in.
all right.
And that's really the journey, right? And essentially that tooling sort of, as you got more professional, well, actually, I need to run it overnight, right?
Mm,
I need to run it I need to be able to catch all the errors and cope with change. So that's that migration from Excel to, well, actually let's do the industrial bit, the hard
Right.
bit in Perl,
Right.
because it gives us more flexibility, allows us to deal with data on a record by record basis and process it,
Mm.
right? And then you had your outcomes. And then there was another wave where the ETL wave, where we would load the data into a database. The data engineering was, okay, let's just get it into the database, and we can use the database structures and tools because Perl and OO languages
Right.
on structure tend to operate on a record basis. So once you're in a database, if you need to deal with 1 million records or
Right.
5 million records, right, actually it's a lot more effective to do the same operation
Right.
on 1,000 records as one. So you had that journey through time. And to some extent, if you look at pandas and the way that Spark and modern tooling works, it's more
Right.
a hybrid of both. So you take functional programming and you take an operator to act upon a set of data based upon a set of conditions. So
Right.
you've got the best of that, that Venn diagram, that set mathematics approach to
Right.
database processing, to the high performance analytics, flexible nature of using Python or using Spark/Scala
Right.
for that big data performance. So the key drivers for all of this, right? You've got that standard ETL framework, but you know the so this brings it back to my background in business,
Right.
background
Oh,
in
okay. Right.
economics. So the drivers for all of these things are, we need to do things more efficiently, we need to do them less often, and we need to do them more effectively,
Right.
right?
Right.
So how do we do that? How do we deliver that? And there's always trends, and there's always things changing in the industry, and in what the latest, data lakehouse is the big trend in in the big data Spark world. But
Right.
that's not that far away from structured data schemas going back 20 years.
Right.
The language is different and the technology is different, but in the thinking, right, it's very much, how can we get the right data in the right place at the right time, quickly
Right.
and efficiently, so we don't need to mess around with it too much.
Nice.
So that's really what's changed. Fundamentally, that's really what's changed. It's like, well, the technology keeps moving, the thinking keeps evolving, and this is the key element of what we're doing. Because how do we get, you know, the important thing? How do we get the data that we need to make good decisions in a business,
Mm.
right, into the right people's hands in the right forms, right?
Right.
Because nothing else is that important. If we could literally, my one of my first jobs years and years ago, right, I was working with a guy, helping him calculate the yield, work out the yield curve for inflation-linked bonds,
Right.
and we hadn't really done this at JP Morgan before, and the algorithms existed, but there was a problem with them, and I spent a month on it. I could not figure out what the problem was. So I
Right.
ended up rewriting it later on. But largely, I spent a month going to a Bloomberg terminal, and this guy used to sit on the floor behind me as a graduate. This is he asked me, well, if you can't do that, can you make sure my reporting's straight? So I tried to write a program to do it. It's a bit hard. Didn't have the skills, didn't
Right.
have the knowledge or the experience to be able to do it. But actually, what he wanted was already on Bloomberg. So
Right.
every morning I used to get in half an hour before him, print out his reports from the previous day, right, staple them together and leave them on his desk,
Interesting.
right? Find the right solution to the problem. Though
Mm.
code is not always. This is the point, right? And we've had this conversation,
Yeah.
collectively at BigSpark before, right?
Right.
Because sometimes code's the right answer. Doing the right thing in an engineering context
Right.
is really quite powerful and can drive the company forward and drive the projects forward. But
Right.
actually, when we're doing these things, when we're doing data engineering, what is the thing that would add most value? Copying
Mm.
that field from the file to the database,
Mm.
maybe,
Mm.
right? But actually, just getting it 80% of the data in there and working and
Right.
having a report with the understanding that we've explained to the business partners, it's 80% there,
Mm,
might be enough.
mm,
So your time to delivery is really important. And
mm,
that's the new wave of data engineering tooling and capability, right?
mm,
Data completeness and data quality are really critical, but they're critical in terms of understanding what you've got rather
mm,
than, oh, we can't do anything until we've got that thing done.
mm. Right. Right.
So I've drifted off your question quite
No, it's
significantly.
actually perfect because I think the way you segued into, code is not always the answer. I remember I was having a discussion with McLean, even, ahead of, preparing for my podcast, and we said something like there was one of the points like, don't develop that feature, or don't write that, like don't don't code that feature or something. I don't know. Like, remember, McLean, can you remind me?
Agni, Agni, you ain't gonna need it.
Exactly,
So
like you
if
ain't
you
gonna
don't,
need it. So it's actually, it's actually around the same, topic of, code may be good, but then the other crucial things that you have to take into consideration as you progress. Speaking about projects, I just want you to, expound a little bit about your like maybe one interesting unconventional project you've worked on, one that you found, a data engineering project preferably, one that you found very interesting, unconventional, if it is, and just tell us a bit about the problem, how you solved it, and what the results were, possibly.
So it's interesting because it was a sort of inflection point in my career. So
Mm,
I had done a load of work with a company called Swiss Re on their data. It was called RDB, reporting database,
right,
and it had an Excel front. It had a VB front end, and it was great. It was quite innovative at the time, but
right.
it was coming to its end, and I sort of left that um, just around the same time as the 2012 Olympics. So in terms of job market, it was really quiet, and I ended up seeing on LinkedIn, oddly enough, a friend of mine saying, "Oh, anybody looking for a job right now?" I went,
Mm.
"Yes."
Okay.
Um, and a guy called Alex McClintock. Hit him on LinkedIn. He's a good guy. He's an interesting guy. And I joined him to help build out a fashion analytics platform, which is still running. If you want to Google for WGSN in stock,
Okay.
um, and I learned far too much from most blokes should ever know about women's apparel. Um, so largely what it did, right,
Right.
and fundamentally the project was all around gathering data around women's clothes. Yeah, and my role was really. I remember at this point I was a Java developer. I hadn't done a lot of. I hadn't done. I'd done one prototype on big data
Mm,
historically, and I hadn't really touched it before. And it's a very, in some ways, it's a good straitjacket to get into, because
mm,
it stops you worrying about stuff. It gets you focusing on the problem, and actually you have to fit your solution to your problem in a very tight box.
right.
Whereas most programming tools give you as much freedom as you need to do whatever you want. Back then, Hadoop was all about map reduced, and there wasn't anything else. There was no Spark, there was no Scala. There was just map reduced, and nothing else.
Right.
So largely, this platform took data, scraped data, which was provided by another team, um, and then basically created large files, which we then had to parse, categorize, classifies the data, grab all the images, resize them, make sure they were in the right place, and then publish them. And we shoved the whole lot into a big Elasticsearch index for us to
Right.
then serve us for website. So
Right.
we were interested in things like what the images were, what the material composition were, what the
Right.
prices were. For example, if you, for example, take a little black dress from Marks and Spencers. Now, some of these companies may no longer exist, so forgive me, I'm not au fait with this stuff anymore. If you take a little black dress from Marks and Spencers and come from River Island or from Reese or one of those other bigger fashion companies,
Mm,
all right, you've got you've got a variety of price ranges for different consumers. But you've also, what drives that is not only the the brand and the brand impact, but also the materials and the composition of the materials. So those are embedded within the the data that's scraped off the web. So we needed to, each one of those companies have a different format, and each one of these materials may have a different name. So understanding that and putting together analytics and driving a model whereby we could take what we think is the same thing through potential, image analysis or
Right.
price analysis, or just, actually sometimes it just was called a little black dress, right? And then we can, for each of the retailers, we could then understand what it was made up of and where it was made. And from the back of that, we could sort of compare where all of the um, materials came from and what was the constituent pricing. And you then had a product where merchandisers and buyers from like retailers would come and say, oh, okay, we're interested in that data. Let's have a look at what's happening
Right.
in the market.
Mm.
And that's all where it came from. So that was really my first big data project. First on Hadoop on the cloud, first interaction with Cloudera ever, first interaction with Elasticsearch. Um, and my responsibility really was to take the data, build all the classification rules, make sure the data was modeled correctly into the data store. We use a tool called Pig, which nobody uses
Nobody
anymore.
talks about pig these days.
No.
Yeah.
But yeah, transposing Pig Latin into Python is fairly trivial. I suspect there's a tool that will do it automatically now.
Definitely. Especially with the rise of AI tools, definitely. Even before AI, it was definitely there.
Exactly. I think I might have written one as well, because I didn't like Pig very much.
Hello there, Tech Surfers. I have got some news for you. The Tech Surf podcast is now on Instagram and LinkedIn. Follow us on Instagram at the Tech Surf podcast and LinkedIn, the Tech Surf podcast, to stay up to date on new episodes and to get interactive. Don't forget to like, share, and send us feedback on your favorite episodes and the lessons you've learned. See you soon. All right, so let's delve a little bit into, the topic of data engineering or a data engineer. So you have been in the space, you have seen quite a lot of, trends, development whatsoever. And there's a lot of hype, currently in our industry, AI is taking over a lot of things, but we'll get into that later. What would you say, as one who has worked as a data engineer, hired data engineers and training data engineers, what would you say makes one a good data engineer? Maybe your top 5 skills or top 5 things that you would say makes one a good data engineer.
Um, so I'm probably an outlier in a lot of these things. So the way
Right.
I assess people and understand skills. So number one is curiosity around what we're trying to do. Right. So I mean that in so much. What I mean specifically is, how do we talk about when you're given a task in terms of data engineer, the guy that goes, I say, oh, can you just build this table for me? And I'll say, oh, here's the schema, here's this table, and I appreciate the people who just say, yeah, fine, Shaine, and crack on with it. That's brilliant. I really appreciate that. Right. The guy that comes to me and says, that's great. Who's it for? Why are we doing it? When does it need to get done by? Right. And what are the acceptance criteria for outcomes? Right. That sort of interested is really important.
Right.
Yeah. Now if I can expand into why if you want me to, but number two, languages are not important, right? But given that, if you don't understand when I say, oh, I want Cobb normal form or a star schema, that would be bad, right? If you need to understand the difference between writing something in an OO language or a function language and being able to write those scripts. So, as a minimum, you need to be able to shell script. You need to be able to interact with a database. You need to be able to write in a functional and or object-oriented language. These are all really quite important skills because for me, the languages and the tools are a tool bag, right?
Mm.
When I started my career, I had a hammer,
Okay.
right? Java is a hammer, yeah? It's
Sure is.
great, but you could do lots of things with a hammer, right? But finesse is not one of them,
Mm.
right? You can do finesse if you're good, and it requires skills, and that's why over time you add, you know, the great thing was like, but when I was probably 2005 to 6, there was loads of books on learn these 5 databases,
Right.
right? Those books still exist, and I would recommend, you know, um, knowing more than one NoSQL database, knowing a relation database, knowing, Python, knowing having a go at Rust, because they are different skills and different approaches to solving
Mm.
problems,
Mm.
and it's all about solving problems, right?
Right.
Um, organization,
Mm.
right? Organization, right? If you, if you, if you're okay, I am not an organized person at the best of times,
Mm.
right? I am bloody chaos, right? When I'm trying to do more than one thing at a time. When I'm focused on doing the one thing, I have a very structured approach,
Right.
right? When I write code, I will write the pseudo code on the page on the paper, and this data engineering software doesn't really matter, right? I will write what I'm trying to get out of each function, and then I'll restructure it so that I've got the structure that I want
Mm.
with all the steps, and that'll drown out a lot of things. I can
Right.
turn those to BDD tests. I can turn those into a documentation, right? Gives me flexibility, right? But it also, what it does, it gives me, well, actually, this is a bigger job than I expected. So
Mm.
I know almost straight away, within a few hours, I've taken on the story points I gave this piece of work are much, much greater. So
Mm.
much less than I should have done. At that point, I can flag that, and I don't need to wait for the next Scrum meeting the next day. I'll say, oh, I messed up here. Scrum Master, I messed up here. This is more complicated than I expected. Can
Right.
we? Can I? Can I? Yeah, I need to revise this estimate. It's wrong, and this is why it's wrong. So that
Mm.
that means that we can communicate out to stakeholders way in advance of when it becomes an issue,
Right.
right? Um, Actually, I touched on the last one, communication,
Mm.
right? Um, when I'm under pressure and under stress, right, one thing I do is I'll switch off projects and I'll switch off my outbounds until I'm focused on the thing that's causing me stress, right?
Mm.
That's good for functionally delivering what I do, but all of the other things I've just abandoned, right, will cause problems, right? That being able to maintain the communication, um, be really polite and but be really clear around what not needs to be done. So
Right.
again, that approach to that, the approach to communicating out, defensive programming, data
Mm.
engineering is all around data is rubbish. Generally, right? I should write that should be the book. If I'm going to write a book, it's going to be named Data is Rubbish, right?
That's
Because the majority of the data out there that we've consumed, if I get a hit rate on the model of what I expect the data to look like, it gets about 60%,
mm.
right? 40% is always like there's always something wrong with it,
Right.
right? So if you have a strong schema validation upfront on inbound, you know what your problems are before you've even run your script. But when you run your script, if something says it's going to be a float, right, check it.
Mm.
Right, make sure you can do the conversion before you do the conversion, because you've got the difference between a checked exception and unchecked exception. Sorry, I'm really dialing down here,
No,
right?
no, no. It's actually good stuff here, but yeah, we like it. Keep going.
Yeah, but this is what I mean. The point is, a runtime exception from a programming perspective, right,
Mm.
is expensive
Mm.
because you've got to run the stack and it comes back, you got to catch it, and you go back into the float.
Right.
Whereas a checked exception, you can go, oh, is this field a float? Can I convert this thing to a float? The answer
Right.
is yes. You just progress. If it's no, you go straight onto your error topic.
Mm.
Sorry, I'm thinking very much in streaming in real time. If you
Well, we
think
like.
about batch terms, yeah, we like that, but that's not that's
Yeah.
that's tomorrow's world. That's not today.
Defo. Defo. Definitely.
But the point is, you can triage that data, right?
Mm,
And sort of the final big one, I think I've got to five. The final big one, right, is the guys that ask themselves, what would happen if they get woken up at 5 o'clock in the morning and they
mm,
have an hour to fix this problem, right? What logging, what monitoring, what other stuff have you put in place that
mm.
makes their life easier? Because them is probably going to be you,
All right.
right? And I've learned that the hard way, having been woken up to fix my own rubbish code at 3 o'clock in the morning
All
and
right.
having no sleep, small child screaming in the background, and having to fix things on the fly,
All right.
right? No fun whatsoever.
All right. All right. I find that to be very interesting how you have just, I think you've taken all the points and you've really drilled down to help someone understand. Because when I was in school, I happened to have, just done one course of data engineering. And the first work I had done was to, calculate the TF-IDF of, a bunch of text and everything. And then we saw it from the point of, sourcing the data, doing all that. Now I knew that as big data or data engineering, but I didn't know what it meant to be a data engineer until I started working at BigSpark and seeing the different portions and like how you have broken these skills down. I think it'd be very good for someone, even for those who are currently in that role and someone who is yet to get into that role, to think holistically about their problem solving approach, both from the technical bit and also from the human bit, so that when you are put into such situations, you have more control of what you do. So I believe that is very great. Speaking about big data and all that is going on in the space, like you were making reference to real time, like batch and streaming and all that. Before we even get to that more, there are a lot of things that are going on in the industry today, and you have been here for for a long time. If in the shortest possible time you can tell us a bit of the misconceptions you've seen over the period of time and maybe debunk one or two of them, if you can. the, um, it may not necessarily be data engineering, but tech. I know it may be a controversial one, but we like a controversial Shane.
Um, I think so. Okay, data science, right,
Right.
is sorry, I shouldn't say this, but yeah, basically, you know, I've worked with models and with you know with data quite a long time. Data science, right? Some of the models that I've been given to productionize have not been good,
Mm,
right? Largely, to implement, taking um, applying standard models to problems is going to be, which is what a lot of data science do. They just try various models with the various frequencies, right? With different approaches, and depending on which gives a better outcome, we'll say, okay, this is the thing to use, which
right.
is which is the standard approach, right?
All right.
It's not. I don't feel that that's a hypothesis driven. But the other thing is, um, I think this is obviously an opinion that um, largely, as AI sort of drives through change and we can get better data into AI models,
All right.
um, largely that role will get smaller and smaller.
Mm,
Okay, awesome. Um, yeah. So Shane, I can't remember when I entered or when I got into data engineering. A friend of mine, Joe, who we all know, and he's been on this podcast before. He showed me a site that I think it said, is it a Pokemon or big data, right? Because there were a lot of, there are a lot of data engineering tools, and also like numerous billions of ways you can use it, right? So, how do you approach the trade off between building your own custom data engineering solution, right, versus using an off the shelf tool? What services or what factors influences your decision in making or going with either approach?
Who's going to use it? What's the ecosystem? I think I wrote a blog post a few years ago on choosing the right, um, making technology choices. And so Okay, so I've done some product selection for various companies over the years, and one of them was all around the team that were going to use it. Right, I needed a low code solution that had flexibility to bolt on, other languages, had certain factors around, result reliance and scalability that were sort of key. Right, and those were driven by not by me personally, but by the environment that we're in. So you've got those. If you think about that force diagram, it's like, well, the biggest force is like, well, what what are the skills of the guys that are going to use it?
Mm,
How are they going to leverage it, right? And what's the route to life? That's
mm,
one of the big drivers, right? And the other driver is, well, what's the policy from a company perspective? What's their approach to technology, right? Because the reality is, if they're not going to allow those engineers to ever deploy production pipelines, right, to an environment, then essentially you need to take a very different approach to, well, actually, we can be quite pragmatic and quite smart around how we deliver change. So the underlying technology, they're all much of a muchness.
mm,
Whether it's DBT or Fivetran or stream sets, which obviously I know well, um, or actually just writing pure Python and running them in lambdas,
mm,
right, or data stage or whatever, or data step. It's all much of a muchness, but it's the thing that the primary thing that gets missed for me, right, is testability, data testability. There's no product in the market. Monte Carlo and there's a few others, but largely nobody solved. Well, how do you do BDD for data? Behavior driven design for data. I don't think there's a solution for that. It's a gap in the market. And I thought about it a bit, and it sounds like a hard problem. So I went and did my day job. It's great. Um, so that's sort of key. Um, how do we? What analytics do we provide on the data as it journeys through our systems? Right. What metrics do we capture? That's sort of now called observability. We just used to call that data metrics and metadata, but now observability. All right. And the third one is velocity. Right. From me, right, when I do product selection, it's different, right? Whether I need to run things on a batch or real time, I'll make different decisions,
mm,
right? If I have a absolutely crack, you know, suite of high core Java devs, right, I will make a very different decision, and you know that core team plus the appetite of the company to build versus buy, I will make a very different decision from that compared to, oh, I've got a load of people that are historically analysts, used to Excel, very much just will hack stuff together to make it. I'll want to put a much more structured, a lot more, prompted development routines into them so that actually I can templatize a lot of the things that they would do,
mm,
right? Validate the connections up front and basically give them a put your code in here. So it might just be get the data into a database so they can write their SQL queries, a la Snowflake. That's where the DBT use case is really useful, right? Would I choose to write if I was running a platform and it was my job to write the pipelines? Would I choose DBT? Not in a million years.
Actually, do you have any issues with guys from DBT or?
DBT is a great tool, but it's a database tool for doing stuff in a database, right?
mm,
Having been the guy that's written that for years, right? It gets to the point where it's limiting,
mm,
right? When you want to do actually clever stuff on the data, right, you'll have to write interceptors to do it, right? And you can do that in Snowflake. It does work, but why give yourself that grief when you could, if you've got a good development team in Python, right, have it running through a stream of consumer producer of your transformations and have an observer watching the data and extracting out your metrics and sending them over to sending them in real time to Splunk or to Elastic,
mm,
in which case you get your observability for free. well, not free, but it's like you don't have to do any work to get there.
Got it.
Did I answer your question, or did I talk around it? I felt like I talk around it.
Yeah, you talked around it, but you answered it too. Yeah. I mean, data engineering. Well, I found it to be sort of interesting and also tricky, right? I mean, the data that you provide, you don't know what the data, or you might or might not know what the data will be used for. Um, and also, you don't know the decisions that will be made based on the data that you are building the pipeline or whatever you're doing it for, right? And my experience, I know we've all heard of the butterfly effect,
Mm,
and what what rather something really really small might, I mean, um, have a big impact on something that you might not know, right? So I'm wondering if, in your case, um, if you experienced a situation where a seemingly minor oversight in data engineering had a major consequence in your organization. Because I know you have experience in working in big organizations. So I don't know if you have um, an instance where you can share with us.
God, yeah. So you remember I talked about index-linked bonds earlier on, and
mm-hmm,
I said I didn't know, I couldn't fix the analytics,
mm,
right? I just didn't know. It took me months to figure out what the problem was.
mm,
In the end, it turned out to be the inflation curve, right, that was coming inbound from a different system, right, had some bad data in it. Right, because I hadn't written validation on the inbound data, I just sort of said, "Oh, this is the inflation rate for the last." I think you needed like, it's been a long time, but about 3 years worth of 2 or 3 years worth of data in order to
right,
work out what the curve was, the historical curve, and then you'd interpolate it out to the future points, and that's how you'd calculate the curve. Because okay, for those of you who don't know, an inflation-linked bond, right, is you lend, for example, the UK government £100, right? They pay you back based upon the current rate of inflation plus a margin on top. So the inflation right now is, I don't know, 6.5% off, 5 points, so whatever the number is, right? The government will pay you an additional 1% or 2% on top of that. So, in order for us to work out what the future yield curve is, we need to interpolate what we expect inflation rate to be in the future,
right,
right? And then add the margin on top, right? So, the only real way of calculating, you know, future expectations of inflation, there are other ways, but in this simple example, was to take the historical inflation rate curve and to say, well, historically, this is what the curve would be, and we do some interpolation, and there's some other factors to it, but fundamentally, that's it. But because there was a spike where we had bad data for 1 month, right, and I literally fixed it, right, by ringing up the guy who produced the file, because it was a bloke back then that copied it off of somewhere, some spreadsheet or something, right, saying, "Oh, this number's wrong." He went, "Oh yeah, of course it is. Let me go and fix that." And that was literally it. So when we talked about defensive coding and programming stuff, so that's what I mean by the butterfly effect. A tiny oversight of the decimal place was in the wrong place, right?
right, right,
Yeah.
Right. In a CSV file with, you know, 500 records in it, 1,000 records. I can't remember. This wasn't even a big file. But the thing is, if you scan through it in Vi, right, you couldn't see it. It was mainly because the font I was using was bad. Okay, that was another thing. Sorry, data engineering skills. Use the right font.
that was a good one. That was a good one. That was a good one. Speaking of, okay, now we do, so okay, so now we're going to move away from data engineering a little bit because I know you, Shane. You are super busy. Anyone who has worked with Shane knows that the it's work to get Shane because he is very, very, very busy. So the work added to getting Shane is also a task. It's a non-trivial task. So when you get him, you milk him down, you drain him of all the energy you can get, and then you go on to the work you can do. And I do admit that you have a very busy schedule. What do you do to, wind down, relax, with everything? You're a father, you're a husband, and I know you're a rugby coach. I don't know, maybe you potentially a singer. Maybe you can, show us some other parts of you, creative sides of of your life that we do not know about.
I don't think there is. I think you've pretty much covered it there. I, so if you guys didn't know, it was the 30th anniversary of the release of Civilization yesterday.
Oh,
So
wow.
yeah, I spent a couple of hours playing Civ,
Interesting.
um, which was fun
Right.
in the evening. But yeah, apart from that, I read a lot.
Mm,
Read probably too much. Oh, book du jour.
mm.
I'll lend this one to you, Raymond.
I'm gonna take it. Thank you. What
It's
is it?
called Order Out of Chaos by Scott Walker. It's
Okay.
from a kidnap negotiator and
Oh,
applying negotiation techniques to everyday life. It's really good.
right,
It's
right,
really good in terms of
right,
effective communicating
right,
in difficult situations. That's what it's all about. It's really good. Really big fan.
right,
Okay, yeah. So yeah, if you see, I'll just turn my camera around. There's lots of books and my lunch that
right.
I sort of float on.
Mm.
Um, I play the piano very poorly
Oh,
and the guitar,
okay.
singing guitar. Um, and that's about it, really. As you said, I
Mm,
sort of coach a bit of rugby. I
mm,
did do choose for rugby. I
mm.
think taking that time out to okay, now I'm gonna do a story. You know me, can't help a story.
That's fine.
There's a film with Hugh Grant from many years ago called About a Boy,
Mm,
um, and Hugh Grant's this sort of character that's independently wealthy, right? But it's really important for in order for to exist where you don't need to work, you don't need to. He's not got relationships. He's in his own little box. To have purpose, than to live purposefully.
right.
His purpose was terrible, but it actually struck me. I remember watching it at the cinema in Edinburgh in the Cameo Theatre and watching it on the big screen. And
Mm,
he went through how a man with no purpose
mm,
ingrains purpose into his life. He
mm,
splits the day into small chunks. He applies it to different things, like, I'll go for coffee and I'll make breakfast, it takes me this long, and this is what I like to do. And I'll go
right,
out shopping and I'll do this, and I'll find records, and I've got my record listening time.
right.
Now, my time tends to bleed into each other. As you said,
Mm,
it's things get busy,
mm,
but making time and making the opportunity to do other things is really important.
mm,
Um, Now, I write a bit. Um, I read a lot.
mm.
I like, I run a bit. I eat too many cakes. That's probably not a good thing. And I do too much poor DIY, which my wife curses me for.
Mm. That's all right. That's all right.
Yeah. Shane. So let's say, well, we are Raymond and myself are engineers, and we work under you actually, and you're a fantastic boss, by the way. Um,
Oh yes, you are.
yeah,
You are.
but but I mean, anyone who says otherwise is obviously telling lies. But um, so right now we all aspire to be in your shoes one day, right? So my question for you is, how do we get there from where we are?
Mm,
For those who don't know, I'm a senior engineer at BigSpark, where Shane is a co-founder, and I will also want to be, if not a co-founder, the head of an organization one day. So I'm wondering, Shane, how do you get there from where we are?
Um, yeah, I'll probably tell this. Okay, so it's really important, right, that each person has their own journey and how they get
mm,
there. Each person has different sets of skills that they have and they can develop, right? Now, there's two, there's two models of the world, right? Right. You can either expend your time and effort in life, right, working on the things you're not good at, right, and making them less of a weakness, right? Or you can focus on the things you're really good at, right? Understand your limitations, work mitigations for them, and be really, 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 really good, Focus your energy and your time and your will on the things you enjoy and you're good at. Generally, those things correlate. Being good at enjoying, they're normally the things that make you different. Now, take one of the key skills for software engineers and engineers is to be able to tell the narrative of why we're making technical decisions and how, and articulate them. Right, that is probably the biggest skill we have. Right, and without it, we become techies. Like sometimes you fall into that role because it's needed because of the meeting you're involved in. But largely, right, how do you get people to understand why we're doing something technically driven by a business requirement? What's the narrative with not using our words, using different words, right? Being really good at putting yourself in the place of the person that I mentioned, pretending being that support guy. Put yourself in your boss's shoes, or the guy that's paying your bid. You're paying for your work, or the guy that's going to have to take up support or doing the testing. Right? Have an appreciation for the things you do. Right? Because one of my biggest regrets is that I didn't value other disciplines when I was earlier in my career. What's this data analyst nonsense? I could do all that, and I could. I was not bad at it, right? But then I met an amazing girl called Claire who joined one of my teams, and she was foisted on me. I didn't want her. I didn't think she was necessary. It was just like, give me another programmer, please, because this is stupid, right? She joined my team, right, and made everybody more productive because her ability to look at data and analyze it and progress through things. So part of this is the understanding of what I bring to the table, right? What I don't bring to the table, and what other people bring to the table. Because when you lead an organization, right, what you think you can do and what you can actually do, right, are very, very far apart. Right? Your material ability to change things and drive things forward as you got more senior has little to do with the actual typey work that you're doing. It has very much to do about coaching, mentoring, setting expectations, understanding budgets, understanding forecasts, understanding how to organize and structure teams to deliver outcomes and communicate those outcomes effectively. Right? Like, and that's when you change from being I think there's some language around contributor and inputter. There's loads of words around this. But as you get more senior, essentially your ability to take that step back, go, okay, what are we actually trying to achieve? For example, okay, right now, right at my day job, right, I'm being asked, right, I think we should take a certain path. Right? I'm 100% sure that if we do this, life will be better for everybody. Right? I've given them the instrumentation. I've given them the metrics. I've done the analysis. I can prove it. I can prove it from a finance perspective. I can prove it from an outcome perspective. Right? But from a program perspective, right? There's no appetite to do that piece of work under any circumstances. Right? There is appetite to take another path, which I don't entirely agree with. I think it's going to end badly. But in the end, right, we as a team, right, need to sort of focus and deliver on the outcomes. And sometimes you have to do things you don't want to do. And you have to do things that you need to do because that's what the outcome needs. So to answer your question specifically, right, understand. So let's take it from top. Understand, right, your strengths, your weaknesses. Understand there's always the opportunity to turn your weaknesses into strengths and to be that good, right? But to be honest, sometimes it's just not worth the hassle, I'll be honest. It's just not worth the work. There are people that are going to be better than you at doing that thing, and you just need to be clear with other people what that's going to be doing, right? Appreciate the people around you, right? There was a guy I worked with years and years ago who I was sitting there moaning because I was doing this horrible piece of work. I hated it. And he says, well, you played really well. You're sitting in a lovely office with really nice thing. If you can't find something in the work to enjoy, right, go do something else, right? Because just too much. So that whole Marie Kondo thing of sparks joy, right? In the work that we do, right, there's not much that sparks joy in sitting and chunking through an Excel sheet and doing forecasts. But actually, I quite enjoy it, because over the years, I know the impact of doing that really well and being 100% you've done a good job, right? The impact of doing that thing is really important. Appreciate the people around you, appreciate the skills they bring to the table, work with them, and understand the things they bring to the table. Put yourself in their shoes. Try to one thing I've learned from the whole Brexit thing is that my job isn't to persuade people to change their minds. People don't change their minds, right? You need to figure out how to get to an accommodated position with everybody around the table, right? That you can all support and move forward with, right? Collectively, because that's how you achieve great things. Because if everybody's going different directions and we're trying to do different things, we don't have common purpose, we will fail.
Right.
And whether that's in our personal lives or our family lives or anything else, right? That's where, or work. Now, that's always the key marker for me, right? It's just work in the end, right? So that's another thing. It's just work, right? You need to have stuff outside of work that sits alongside, that gives you my best contacts, right? Mates that I've made at work because I've tried to be a good bloke. I've tried to be nice to people. I've tried to make friends and influence people. Going back to Dale Carnegie. But actually the majority, the large majority of other people I've met have been through rugby or football or, I've got a whole online, friend group all around the Wheel of Time randomly, right? That I don't message that much anymore because the series ended 10 years ago. But, they still, I can still see the occasional LinkedIn, WhatsApp messages or LinkedIn messages to talk to them. The next thing is read more, right? You may not learn things from books. You may not pick up, but each book I've read, there's been a nugget. There's been something new in there that I've been, I could use that. And I've got better for reading widely and reading management and reading technical books and reading fiction. Just, it is a good skill, the ability to take a 118-page PowerPoint and being able to summarize that quite quickly in your head in terms of a narrative, right? It's not something that is a skill. It's not something that comes from talent. It's something you do repeatedly till you get good at, right? And that's it. The last, potentially the most important thing, right, is something actually that I heard on the radio this morning from a high hurdler called Colin Jackson, and he says, well, you need to be in the environment to be the very, very best you can be, right? And as long as you're trying to be your very, very best, right, and taking the opportunities that scare you, right, you will progress and you will get better and you will make mistakes, right? And those making of mistakes, right, aren't to be feared. They aren't to be ashamed of. They are a badge. Like, my God, the number of times I've literally thought I'd destroyed my career, right, by doing something incredibly stupid, right? And I doubled down. I worked hard. I got on with my job. I put my hand up. Mea culpa. I messed up. I need to do better next time, right? Own your mistakes because actually that's the only way to learn, right? But you need to appreciate your mistakes. Like, for example, Raymond's seen me in presentations, right? When I'm prepared and I'm in my in the right headspace. But what he doesn't see is the 2 hours or 3 hours before I've spent replaying what I'm going to say in my head, and the hour afterwards, that's one of the skills that I do have that probably is fairly rare. Is that I'm quite good at I've got a good memory for those conversations, and I can replay them endlessly for days and days and days until I get them right. Right, I'll replay them in my head until I feel like I've said the right thing or done the right thing or behaved in the right and appropriate way that will move the conversation in the right direction. And that's really important because being able to read people, being able to understand them, the technology will get to a certain place. It really will. But the personal skills and the ability to close out work effectively and to communicate that is probably how you progress more than anything else.
Wow, that is a nice way to end today's episode. I have nothing else to ask. That was a very nice, and nice way actually to end today's episode. And I think for me, my major take from your final words is to own your mistakes and to learn from them and not be afraid of them. I think I like that term. Your mistakes are like a badge. We do see, a military man and all that, come back with, different badges, sorry, based on the thing that they have achieved. And that is what the wealth of experience, the wealth of capacity that they have built over a period of time. Shaine, thank you so much for making time, and McLean, thank you for showing up today to make this episode a very fruitful one. I really enjoyed it a lot, and looking forward to sharing this episode with everyone, and looking forward to also applying the things that we have discussed here in my career. So thank you so much.
Yep. Merci beaucoup, guys. Have a good day.
You too. Data engineers, without a doubt, have an essential role to play in helping organizations unlock the value of their data. To truly stand out in this field, Shaine reminds us to have a curious and investigative mindset in order to get the best insights from this newfound oil. Thank you for listening to today's episode of the TechServe podcast. See you in the next episode.